Welcome to Module 1 of the Intro to BMM class. If you're excited to explore the revolutionary world of the blockchain maturity model, then you're in the right place. In this module, we're going to define the target of the BMM. Specifically, you'll learn all about what the difference is between a blockchain and a blockchain solution. So if you're ready to get started, let's go. As you delve into the blockchain maturity model, you'll come across the term blockchain solution quite frequently. To make the most of this model, it's essential to understand the concept of a blockchain solution. But before that, we need to define what a blockchain is, because this sets the foundation for everything that we're going to talk about moving forward. If you ask several blockchain experts about a definition of blockchain, it's amazing how many different answers you'll receive. It's not that any of them are right or wrong. The bottom line is that there are many different definitions of blockchain. Let's start with NIST. The definition that NIST has in their blockchain technology overview is that blockchains are tamper-evident and tamper-resistant digital ledgers implemented in the distributed fashion, i.e. without a central repository, and usually without a central authority like a bank, a company, or a government. And they also say that in 2008, the blockchain idea was combined with several other technologies and computing concepts to create the modern cryptocurrency. So the International Standards Organization published a vocabulary, and in it they defined blockchain as a distributed ledger with confirmed blocks organized in an append-only sequential chain using cryptographic links. We decided to model our definition after the ISO glossary definition, since it's an international standard. So our definition is a distributed ledger with confirmed transactions organized into an append-only sequential chain using cryptographic links. What made it so difficult to come up with a definition is that as we were building the BMM, we realized that some blockchains don't have blocks. Some blockchains don't use consensus. In fact, the very first blockchain didn't even have a distributed ledger. But what all blockchains have in common is that making any change to data in a block requires that all of the following blocks of data be reconfirmed. So if you've got a blockchain with 1,000 blocks and you want to change data in block 904, you'd also have to change the data in 905, 6, 7, 8, 9. You'd have to change it in all of them. And of course, all of that would require consensus. So it makes it very difficult to change. This is a photo of Scott Sternetta and Stuart Haber. They were the creators of the first blockchain in 1992 and wrote a paper called How to Timestamp a Digital Document. Scott Sternetta will explain what inspired them to create the first blockchain. It's important to understand the history of blockchain and the initial motivations that led to its creation. Let's listen to what Scott has to say about it.
Looking at that world of the future, I started to worry or even obsess, my wife would say, about the issue of the fact that all of the world's records were going to become digital. And when that happened, there would be no way to tell the difference between an original record and a document that was altered just seconds before it came up onto your screen. And so, to the aptly defined obsession that my wife would call it, I became very worried about how we would create immutable records. Okay? Records that depended only on the bits themselves and not the medium in which they were embedded. And having the ego of a physicist, but knowing nothing about cryptography, when I first showed up at Belcore, I went down the hall and knocked on Stuart's door. He was a very widely known cryptographer. And I said, there's going to be a huge problem in a couple of years. And we should apply the advice that one of my dissertation advisors gave me. This is someone that later went on to receive a Nobel Prize out of Stanford. He said, he was a theoretical physicist, and he said, I try to stay really close to the experimentalists so that I'm the first person to hear any new results. And that way, I can start working on the problem before any of the smart people get to it. And I said to Stuart, I said, this is going to be a huge problem. We should work on this problem before the smart people, get in and steal the thunder. And so he said, okay, let's go for it. And things went well. We developed a kind of yeoman level system but it lacked a certain elegance. And what I said to Stuart was, we've got a workable system, but the problem is it requires you to trust someone, okay? And it would be great if we could eliminate the trust. And so Stuart agreed. Stuart, obviously being the more senior person, he said, okay, let's go for it. And it just so happened that we were working on it for a while, and finally Stuart pulls me aside and says, Scott, I don't think we can solve this problem. In fact, I think it can't be solved. And so to salvage a paper out of this, why don't we prove that this problem can't be solved? And so we were working on the proof, and after a particular day working on it, I went home. My wife, my lovely wife, who's right there, was exhausted, having dealt with our two young children, and so we decided on our budget that we would go to a middle-class restaurant, Friendly's, which is not yet bankrupt. They've been in and out of bankruptcy. At any rate, we're waiting in line at the restaurant, and I'm reviewing the proof that Stuart and I are working on. And those of you that may be a little bit more technically inclined will know that it was a sort of proof by induction where we said, look, if you've got two people and you need to make a trusted record, what if those two people collude? And well, then you need a third person looking over their shoulder. But what if they draw that third person into the collusion? Well, then you need a fourth person looking over their shoulder. And if you continue this out, ad infinitum, you realize that that's not possible. And that's why you can't remove trust from the system. And so I'm going over this, rehearsing this while we're waiting for the table. And I said, yeah, it would be like the entire world in on the collusion. And it was at that point that I realized that that, in fact, was the solution to the problem, not a statement of why it couldn't be done. And the trusted party becomes effectively everyone in the world as a joint witness.
That's what Scott has to say. And to kind of put this all into perspective, 2008, when Satoshi Nakamoto created the Bitcoin white paper, and then from that, the Bitcoin token and ecosystem. In the white paper, there's 8 references. 3 of those 8 references belong to the work that Scott and Stuart did. And like I said before, they created the concept of a blockchain, which was essentially primarily looking at 2 things, right? It was looking at the recording of data in blocks and have that cryptographically connected to the previous block, and then using something called community witnessing to validate it. And that was a concept, and then Satoshi came again, and he added the concept of the payload. In the payload, he put the digital ledger with the token, and that's how all that happened. But it's important to understand that the core issue that they were trying to solve was really, how do you trust data, right? In an electronic world, how can you make sure that it hasn't been altered, it hasn't been modified, there hasn't been some corruption of the data? And so as we look at the blockchain, it really fundamentally comes down to an issue of trust. With that as a background, let's talk about what a blockchain solution is. A blockchain solution includes the blockchain network itself, the applications that sit on top of it, any kind of supporting assets, and all of the resources that comprise the solution. The ecosystem might be people, training, money. It could be a token, a community, anything like that. All of them collectively form the blockchain ecosystem. It's not limited just to a blockchain or just an application, and it's really the entire suite of things that come together that, when combined, perform a function. Let me give you a couple examples to differentiate between a blockchain and a blockchain solution. Blockchains would be like Bitcoin or Ethereum. They're also a solution for a payment system. The Bitcoin and Ethereum tokens can be used for payments. However, if you're looking for a solution to exchange tokens between blockchains, they're not adequate. So you'll need additional functionality in addition to the blockchain. So the function of an exchange on top of a blockchain would be an example of a blockchain solution. It includes the blockchain, the smart contracts, user interfaces, and all of the software code and the community of people that build, maintain, and use the exchange. The combination of all of those resources working together to provide exchange services would be an example of a blockchain solution. Congratulations on completing Module 1. In this module, we discussed what a blockchain and blockchain solution is. We learned that a blockchain is a distributed digital ledger that provides secure and tamper-proof transactions. We also looked at blockchain solutions. A blockchain solution is a suite of resources that work together to perform a function. It includes a blockchain network, applications, supporting assets, and all of the other resources that comprise the solution. The solution is not just limited to a blockchain or just an application, but rather a combination of resources that work together to provide a complete solution. Before we move on to Module 2, there will be a brief quiz to test your knowledge. So get ready to show off what you learned.